Okay, so now we have 4 to go. So here's number 16. Now number 16, split that up a little. This is 15 and 2/5, and that's going to be added to, sorry about that, we're going to add that to 6 and 11/15. Now immediately you should notice that these denominators are not the same. So we're going to have to go through that process. So in the meantime, just ignore your whole numbers and let's just deal with our fractions. So some of you may recognize right away that the lowest common denominator is 15. But if you don't, you can go through the process, 5 times 1, 5 times 2, 5 times 3, 5 times 4, so forth and so on. But we can immediately see we don't have to go any further because here's our 15, and we also know that 15 times 1 is 15. So there you go. There's your lowest common multiple, which is your lowest common denominator. So its lowest common denominator equals 15. Now the second part is coming up with equivalent fractions that both have the same denominator, and the denominator will be this 15. So let's start writing those out. So if we have 2/5, we know our common denominator must be 15, and we have 11/15. So we start asking ourselves, okay, well 1 times 15 is 15, so what you do at the bottom, you do at the top. Okay, and now over here, same thing, we have 3 times 5 is 15. What you do at the bottom, you must do at the top. So you have 6. So here are our equivalent fractions. Sorry, I'm starting to write uphill. So we have this one and we have this one. So let me write it a little bit neater over here. So let's rewrite our problem as 15. Now, instead of being 2/5, it's now 6/15. And we have 6, and now that happens to be 11/15 again. All right, so now we're going to add 6 plus 11 because now we have a common denominator. So that is 17/15. And if we add 15 to 6, that's 21. Now here's a problem though. If you notice, we have a mixed number. So we got to reduce that, we're going to convert it. So whatever the whole number is, we're going to add it into the 21. So let's do that off to the side. So 17/15, remember I always tell you just turn it into a division problem. We know 15 goes into 17 one times. We subtract that out with a remainder of 2. So now I know that it's 1 and 2/15. Now what do I do that with that 1? I'm going to add it into the 21. Okay, so the 21 now becomes the 22, and the fractional part is 2/15. Now that's our final answer. So that was number 16. Let me clear that out and let's move over to 17. Now 17 is 9 minus 8 and 6/7. So if you notice, we're missing a fraction right here. So to compensate for that, we'll take one whole number from this 9. And how do we create something that's equivalent to 1? Well, we look at this denominator because we want to make sure that it has a common denominator. So to do that, over here to the side, 9 is going to equal 8 and 7/7. So that all of that is equivalent to 9. So again, we're not changing the value, we're changing the appearance. So if I rewrite that as 8 and 7/7 subtracted by 8 and 6/7, you could see our final answer, 7 minus 6 is 1, 7. And 8 minus 8 is 0. So that is our final answer right there. So for the trick for the test, this is the piece that you're going to have to remember right here. And again, it's all determined by what your denominator is. All right, let's move on to number 18. Number 18 is y, let me go back to black, y minus 17/23 equals negative 13/23. Now, the goal is, remember that here's your equals, the goal is to isolate this y, get this by itself. And remember, we have an equal sign here. So what we're going to do, so let me let me go ahead and erase that and rewrite our equals. Okay, so remember, anytime that you're moving something from one side to the other, it becomes the opposite. So if I'm going to move this, hold on, I'm sorry about that. So if I'm going to move this over here, then it becomes, if it's a negative on one side, it must become a positive on the other. So it would be a positive on this side. So I would rewrite it as y equals, rewrite my negative 13 over 23, nothing about that changes, but now this 17 over 23 becomes plus, because it was minus on this side, becomes plus on the opposite side. So now I evaluate, and I look and I say, okay, are these the same? They are. So I can write it as one fraction. So y equals negative 13 plus 17 all over 23. And now I'm just going to evaluate it based on the rules I've learned with my integers. And remember, when the signs are the opposite, you're going to subtract and take the sign of the larger number. So our answer is, wait a minute, I think I did something wrong. Hold on. I'm sorry, I hate to do this to you, but let's just ignore that. Let's start over. Let me give you a different one. I can see what I did wrong. Let me try this approach again. So how about if we try this problem? If I have, let me see. Yeah. Sorry about that. Let's try this. This is a better example. How about if we go with y equals, or y minus 17 over 19 equals a negative 2 over 19. I think this one will work out more nicely. But it's the same concept. We're going to take this and we're going to move it over to this side so we can isolate our y. So it would be y equals negative 2 over 19. It's a positive on that side, a negative on that side, so it becomes a positive on this side. Our denominators are the same, so we can rewrite it as one fraction. Same process. Okay, now our signs are the opposite, so we're going to subtract and take the sign of the larger number. So it looks like our final answer is 15 over 19. Sorry about that. I didn't want to have to re-record this entire video just for that one problem, so I apologize about the previous mistake. Okay, so let's move on. We have number 19 and 20, and then we'll be done. Okay, so let me clear this out. All right, number 19, this we have 10x minus 3 over 13 minus 9x equals, and we have 3 over 13 plus 4 over 13. Now we have to work with that. Now we want to make sure that we have the x, anything with the x on one side and all the numbers over on the other side. So let's start there. But before I do that, if you notice, these two numbers, you can combine those. Those are like terms. And if we did a 10 minus 9, we just end up with a positive 1x. Now, if you notice this number here, I'm going to move that over to this side. And if it's a negative on one side, it becomes a positive on the other. So let's go ahead and just rewrite that. So let me just start rewriting. Make that a little bit cleaner. So 1x on this side, and here's the equal sign. Let me just rewrite this stuff. 313 plus 413. Now the number, that fraction I'm moving over, is going to be a positive on this side, 313. So now we know that 1 times x is just x, so we can drop that 1. And we're going to rewrite this as one fraction, which will be 3 plus 4 plus 3, all over 13, because it's a common denominator. And then when we add those up, we'll end up with our final answer. So we know that 7 and 3 is just 10. So we have 10 over 13, and you cannot simplify that any further. So the process was for you to recognize what you could combine before you start moving things back and forth between the left and right of the equal sign. Okay, our last one, number 20. Let's get a clean sheet. here's our final problem. So we have negative 5 over 11y, and that equals a negative 1/2. So the first thing I need to do, I start looking at this, I'm like, okay, how do I get this off the y? Because now it's attached by multiplication. It's not attached by addition or subtraction. Well, if that's the case, all you have to do is multiply it by the reciprocal. So if you have a negative 11 over 5 times your negative 5 over 11y, if you look, and then you finish writing this stuff like that, here's our equal sign. If you look, there's a 5 on the top, a 5 on the bottom, that becomes a 1. 11 on the top, 11 on the bottom, that reduces down to a 1. So, and then a negative and a negative gives you a positive answer, so we end up with a 1. Our answer is a 1y equals negative 1/2, and we know 1 times y is just y, so y equals a negative 1/2, and that's your final answer. Okay, so just to recap some things, let me clear the canvas, and I just want you to remember that whenever and we went through examples as such like 11y over 20 times 4 over 5y, all we're doing is we're going to be multiplying across when we're working on these type of problems. When you have something that's similar like this, where you have a negative 15 over 28 divided by 30 over 7, all we're doing first is we're going to convert that to multiplication and the reciprocal. So let me rewrite that. So it's negative 15 over 28 times, and then flip it, and now we can just multiply across. So all your fractions, whenever you're multiplying and dividing, it's going to be performing the same type of operation. But however, when we go to fractions and we're adding or subtracting, for instance, when we did the problem that was similar to a negative 7 over 20 plus negative 9 over 20, we had to first evaluate, are these the same? If they are, then there's no other work. So all you have to do is rewrite it as one fraction, and then you can perform the operation. But the problem was, when we had anything we added or subtract that did not have the same denominator, then we had to go through the process of finding our lowest common denominator. Then we had to come up with our equivalents. And then once we had that, then we went ahead and performed the operation, whether it be addition or subtraction. So that's the difference between multiplying, dividing, adding, subtracting fractions. And I hope this review helps you. Feel free to reach out to me with additional questions or concerns.